So the top is really just a simple, quick um, review of how to do converting percents to a decimal. Let me just mute everyone. Okay, so remember the way we do this is we just move the decimal 2 times to the left. So remember, usually if the number doesn't have a decimal, it's at the end. So if you move the decimal 2 times to the left, your percent turns into a decimal. This was something you learned back in, what, no, 5th grade, 4th grade, who knows, right? 120%. Oh, really important that you keep 5%. It's 0.05, not 0.50. You have to move it twice. 120% is 1.2. And then 0.4% is 0.004. Now, if we write decimals at percent, we move the other way. We're going to move 2 times to the right. So this ends up being 24%. This is going to be 8%. This is going to be 50%. This is 50.2%. And remember 1.6 written as a percent, I move it 2 times to the right. It is 160%. So that was just a quick little review of how to convert decimals to percents. So to convert a percent to a decimal, all you do is you move decimal twice to the left. And then we are going to convert decimal to a percent. You move the decimal twice to the right. Okay. So hopefully no one really has any questions on this. This is just a quick little review. Today we are doing exponential. We're still doing exponential functions, but we're doing them with percent growth and percent decay. So let's take number 3. And number 3 actually is kind of relevant to today's world. Moana orders from Postmates. Her total comes out to be $20. She wants to tip her driver 10%. How much will the tip come out to be? So hopefully you remember how to do problems like this. Remember, if you are having a percentage problem and you want to find what percent of the total is that, all you do is you just multiply the total times whatever percent. The only thing that you have to remember is that you have to change that percent into a decimal. So this is 20 times 0.10, because I changed the 10% to a decimal, and this is going to be 2. By the way, you'll probably need your calculator for a lot of the work today. So I know a lot of you are just using your phones for calculators, which is fine. And so the total with tip is simply going to be 20 plus 2, and that's $22. Is everyone okay so far? If you have, once again, if you have any questions, just let me know. How do you find the total in B? Well, that's pretty straightforward. We take the total and we add the tip. The total plus the tip. Okay. Now, letter D, you're like, write an expression to represent Moana's total. You might think we already did that for part B. However, I'm going to write D a little differently than just 20 plus 2. Okay. I'm going to write it in this way, that it is 20. Now, what did we do to calculate the tip? We multiplied 20 times 0.10. So that's what I'm going to put here. So this is the same thing as 20 plus 2, because the way I found 2 was I did 20 times 0.10. So Moana's initial value, I know, is $20. Her growth factor, okay, we're going to call it growth factor now because it's exponential later. But just think about she's getting an extra 10%. So that's her growth factor. We're going to write it as a decimal. So now letter C asks, how would you write Moana's total using the distributive property and her initial value as a common factor? So what I'm going to do is I'm going to take what I did for D and I'm going to write it as a distributive property problem. Remember, the way to do this is you factor out whatever they have in common. And what do they have in common? Well, this is a 20 and this is a 20. Then I am going to write 20 on the outside because that's what they have in common. Okay. Now, if I take a 20 out from each of these terms, 20 divided by 20 is 1. By the way, what I'm doing here without doing it is I'm doing that box method that we used to do, the 2 box one. And so we factored out a 20, we're left with a 1 here, and we're left with a 0.10 here. And so this is basically what we did here, except it's written in a distributive property form. Okay, we're going to take this basic example, and now we're going to change it to exponential growth and decay now. So I'm going to kind of move down here for a bit. We kind of ignore 5. That's just the same thing that happened here. But let's kind of remind you what we did on Friday and also on Thursday. Exponential functions have this form, right? Y is equal to AB to the x power. That's an exponential. So we talked about situations on Friday. For example, the cockroaches that are growing under the desk. However, in real life, that's not a real life scenario, right? The cockroaches aren't really going to double every day or week or whatever. And it's, remember those numbers that we got? Like one number we got was like 2 million. We're not going to get 2 million cockroaches underneath something. That's not a very realistic scenario. So now we're going to go into the more realistic scenarios. Things usually don't just double every week, every year. They grow by a certain percent. And so when we have percent growth and decay, we're going to use this same formula, but the way we get the B here is a little different. And so we're going to write this out. So Y is equal to A. So the A stays the same. It's my initial value. But what's going to happen here is it's going to be 1 plus R taken to the x power. Okay, so what does this all mean? Remember that the A is your initial value. Okay. And remember that the R here is the rate but we have to, it's written as a decimal. Okay. And that's what happens when you have what's called percent growth. Okay. Percent growth is if something is increasing by a percent every year. Okay. It's what we're experiencing now with the coronavirus, right? This is it. So let's go ahead and do number 6. A population of deer in a deer preserve starts at 400 deer in the year 2019. The population is expected to increase by 8% per year. Model this growth by an exponential expression to predict the number of deer, where x represents the number of years after 2019. Okay, now my initial value here is 400, and my growth factor, I'm going to change that 8% to a decimal. It's 0.08. And so my equation, if I just follow this, is going to be this. Y is equal to 400, then it's going to be 1 plus 0.08 taken to the x power. Okay. Now, how do we're not done with the equation. It's not simplified. So it's going to be y is equal to 400, 1.08 to the x, because all I did here is I just added the 1 plus the 0.08. Okay? And that's my equation to represent this scenario. Now I'm going to add something here because this is going to be on your assignment. And I am going to put what is the predicted amount of deer in the year 2025. Okay, so I'm going to add that question here for this problem because you're going to see problems like that in the assignment. And so we're going to use this equation to figure out the answer to this. Now, what was our initial year? 2019. Okay, and now we want to predict how much deer is in the year 2025. So what I'm going to do is I'm going to see how many years does it take to go from 2019 to 2025. Well, 2020, 2021, 22, 23, 24, 25. This is a 6-year difference. So what I'm going to do is this x here will always represent time. Okay, so I should actually add that up here. Usually for these exponential problems, time is x. Okay, so what I'm going to do, what you're going to do here is you're going to substitute 6 into this x here. Now, if you didn't attend the lecture on Friday, I told everyone how to do this problem on their phone. Okay, so you have to flip your phone sideways to get the sideways calculator, or press the button that gets you the sideways calculator. And this is what you're going to input into the calculator. I'm going to input it into the chat. It's 400 times 1.08. And there's a button that looks like this, x to the y power. And then you are going to press 6. And then you are going to press equals. So everyone go ahead and try that and see if you get the same answer that I do. If you have a regular calculator, you just use the regular caret button. And so you should get something that says 634.749729. Since we're talking about deer, I'm going to round it to the nearest 1. So this is 635 deer. Okay. Anyone have questions on how we figured that out?
How do you do it again?
Are you using your phone?
Yeah.
Okay. So type exactly this, 400 times 1.08, And then there's a button there that looks like it's X, and then the exponent is the Y.
Oh yeah.
And you're going to press that, press 6, and then press equals.
Okay.
Okay, got it?
Yeah.
Okay, cool. So that's how you do these problems. So let's look at number 7. Johnny invests $8,000 in a bank account that obtains a simple interest rate of 4% per year. So how do I know this is an exponential problem? Because whenever you see it's growing by a percent per year, it's always going to be exponential. Never do a linear equation for these problems. When you see a percent per year, that's exponential. So for A, I have to write the function. So I know this is going to be y is equal to my initial amount is 8,000. And then this is going to be 1 plus 4% as a decimal is 0.04 taken to the x power. Oh, so if you're using a regular calculator, you are just going to use the caret button. So it's going to look like this, 400 times 1.08 caret 6 equals. And then so you have to simplify this even further. So this is y is equal to 8,000. And then this is going to be 1.04 to the x. Okay. So that's how you write the equation. And then it says to use your equation to determine how much money is in the account after 20 years. So once again, you're just going to go ahead and plug in 20 here. So it is going to be y is equal to 8,000 times 1.04 to the 20th. And then so I want everyone to go ahead and try that on the calculator and see what you get. And then I get y is equal to
Do we just round it up or no?
huh?
Do we round it up?
Yeah, so usually if it's money, what I would do is I would actually round it to the nearest cent. So for example, here it's 17,528 and 99 cents. So, because the number after the 8 is a 5, so you would round that up to 99 cents, right? So for number 6, I rounded it to the nearest 1 because we're talking about deer, and you can't have half a deer, 0.5 of a deer, 0.4 of a deer. So I rounded to the nearest 1. But since number 7 was money, we rounded to the nearest cent. Okay. So now number 8. Now we're going to go down in value. So Elsa is using Postmates for the first time. There's a 10% discount for first-time users. Her total comes out to be $20 before the discount. How much will the discount be? Actually, here you do the same thing as the top. You just do 20, and then you are going to do you're going to multiply by 0.10, and you get 2, right? The only thing that's different is it's a discount now. So you're just subtracting instead of adding. So what will the total be with the discount? Well, that is just going to be 20 minus 2, and that's $18. So this time you are taking the total minus the discount instead of before where you added. So if you want to write an expression to represent Elsa's total, it's the same thing as above, but this time I am going to do minus instead of plus. So I take the total, which is 20, and I subtract the discount, which is just 20 times 0.10. By the way, I hope everyone can find a 10% discount easily. If you look at this problem, whenever there's a 10% discount, if something's $20, you just you just move the decimal one time to the left and it's $2. So for example, if something costs $54 and it's a 10% discount, it is going to be $5.40 off, right? 54, move the decimal one time to the left, it's 540. That's a 10% discount. And so when you go shopping and there's a 20% or a 30% discount, all you have to do is find the 10% discount and double it to find the 20%, triple it to find the 30%. It's all really just mental math when you go out there. Okay. Now, so now let's go ahead and answer number 9. Elsa's initial value, we already know that is going to be $20. The decay factor, it is going to be 0.10. So now this is actually the same thing as before, except what's going to be in the middle is we are going to put a subtraction sign. Okay. So the Postmates thing is a one-time thing. Now, if we have something that happens every year, now it becomes an exponential function. So this time, we are going to do percent decay. Oops. And percent decay looks like y is equal to a 1 minus r to the x power. And then once again, what does everything here stand for? The a stands for initial value. Okay, right? The r is your rate as a decimal. And remember, the x represents time. So, number 10, Juanita buys a TV for $1,200. It depreciates by a value of 14% per year. Now, if you don't know what that word depreciates mean, it means it lowers in value. So, for example, when you drive a new car off the lot, it already starts depreciating. It's not going to be worth as much as it is when it's on the lot, right? Depreciates is what you call something losing value. So it depreciates by a value of 14% per year. So now you know it's percent decay. And so now we're going to use a subtraction. So my initial value here is 1,200. The decay factor is 0.14. So now my equation here is going to be y is equal to 1,200, 1 minus 0.14 to the x. And then this is going to be y is equal to 1,200. And now we just could enter 1 minus 0.14 into the calculator, and you get 0.86 taken to the x power. Okay. And so that's your formula. But like before, I'm just going to add one more question here. And I'm going to say, what is the value of the TV after 4 years? So if they ask this question, all you are going to do is you are going to substitute 4 in for x. And so once again, let's go ahead and do that on your calculator. And you should get 1200 times 0.86 taken to the 4th power. And so you get $656.41. Okay, now number 11, I want you to go ahead and try that on your own. See if you could write what function this would be and how much you would get after 15 years. And then I'm going to give you about 30 seconds to do it, and then I'll type in what the answer should be. Okay, so I should get y is equal to 6,000, 1 minus 0.06 taken to the x. Remember, 6% is 0.06. And then so this ends up being y is equal to 6,000 times 0.94 taken to the x power. And then so right here, if I want to find what it is after 15 years, I put in 15 there. And then you should get your answer here as y is equal to 2370. And we're talking about deer here, so I'm going to round. So it's 2,372. Okay. So there are 2,372 deer. Okay. Now, so that's the end of the lecture. Do not leave yet. I need to take attendance. Let me just talk about a couple of announcements. So you are, as I mentioned on Friday, going to have a quiz on Wednesday. Okay. Now, the quiz on Wednesday is not going to cover a lot of material. It's going to cover today, and it's basically going to cover Friday and Thursday. And basically Thursday and Friday are 2 lessons that are kind of the same. If you did Thursday's assignment as well. We did Friday as a class, we did Monday as a class. Thursday ties in with Friday. So that's the test on Wednesday. Now the only thing is on Wednesday, it is going to be timed, and it's going to be at a certain time. It's going to be kind of earlier than when we usually have our lectures, because the school on Wednesday and Thursday are giving protected times to certain subjects, and we are asked to do those subjects on those days at that certain time. Now, the time they set for math is 10:15. However, I know that it's hard for us to get up. I'm setting up the quiz time at 11 o'clock on Wednesday morning, okay? So those of you that have been waking up at noon, please set an alarm on Wednesday. Yes, 11, Jacob. 11 o'clock on Wednesday morning, okay? So just one day, You need to sleep a little earlier, set an alarm, take a quiz, and if you want to go back to sleep after the quiz, the quiz, I mean, I don't even think there's gonna be that many questions on it. I'll probably put some time between maybe like 30 minutes. It's gonna be a pretty short quiz, I think. Okay.
So
Yes.
there's a time limit on the quiz.
Yeah.
For how long? 30 minutes?
30 minutes probably. It's gonna be done on something called Edulastic, but basically I'll just email you guys and you just click on the link on your email and we'll take you directly to the quiz. Okay.
Wait, so what would happen if you like, let's say you missed the quiz or you joined the quiz like 2 minutes?
It should be fine. It should be fine.
So you, would that count with the limited timer? Like you would just have 28 minutes left, or you would still have 30 minutes?
I think it would be 28 minutes if you join.
28. Okay, so it's based on
Actual time.
when you join.
Yeah.
Okay.
Or it's a set time, and whatever the time. So yeah. So I'll answer all those questions. Jonathan, the quiz is basically on today's lecture and on Friday's lecture. Okay. But it's also slightly on Thursday's material. But if you understand Friday's lecture, and there is a video on Friday's lecture on Google Classroom. So if you haven't done that assignment yet, watch it, do that assignment. Couple of things. I will also post a study guide later today, probably in the night. And I'm also going to post a video going over the study guide. So you can watch the video as many times as you want. You have all day. So I'll probably post it sometime tonight. You'll have all day tomorrow to go over it. If you have any questions, you could email me. Don't be shy to email me. No, study guide's not worth points. That's on you, just like it normally is, right? So, and those are my nephews in the background of you here. So the study guide will be posted. And I think that's kind of all the announcements I have. If you are missing assignments, please turn them in. All of you who are attending today, don't leave yet. We'll get an assignment, missing assignment taken off. Okay? So wait until I call your name and then you can leave. Yeah, whoever this is who raised their hand. I don't know who this.
Can we turn in an assignment late?
Yes, go ahead. Jacob, I am actually enjoying the break. I wish I had more. This online thing has been a lot more stressful. I've been doing a lot more work than I think I thought I was going to be. I just want to play Animal Crossing when I'm not getting a chance to.
Mister, can you say poggers?
Why am I gonna? Okay.
I don't know. It's just for fun.
Poggers.
Let's go.
Okay. Join your island. So once I call your name, you can leave if you want to. If you have any other questions, you can. Dolly, do you have something to say?
Huh?
Dolly, are you good? You have your hand raised.
Oh, let me lower it.
Okay, you're good?
Yeah.
Okay, so once I call your name, you can leave. So Dolly, I got you. Angel, I got you. Damaris, I got you. Daniel, I got you. Okay. Dali, I already got you. Hillary, I got you. Jacob, I got you. Jonathan, I got you. Julian, like your email, just turn in your assignments when you can, but I want them in. Okay? Yes, Julian, they are. Lisha, I haven't yet, but Lisha, I got you now. And also, hold on. Give me a second. Karen, I got you. Kelsey, I got you. Lisbeth, you're good. Yasli and Richard and Lucero, I got you. Yes. Enjoy your break, everyone. Okay.